55 miles per gallon. Government regulations dictate that by 2025, the average fuel consumption of new vehicles sold in the US needs to be at least 55 miles per gallon. Electric and hybrid vehicles will likely play a role in the near future, but not fast enough to address issues such as climate change and satisfy our needs. That is why the internal combustion engine is today as important as it has ever been, and why so many people are working on developing this technology. But have you ever wondered what is it exactly that scientists and engineers do in their shops and labs to make this happen? Well, I'm one of those people. And while I could be doing many things, I focus on observing. In the physical sciences, measuring and observing is critical to understand them. The processes that take place inside of an engine are no different, and we need to understand them a lot better than we do now if we want to use them more efficiently. Let me explain. You might have a vague idea of how an engine works. You put fuel into the car, the fuel makes it to one of the cylinders in the engine. Here it mixes with air, burns, and pushes on a piston, and that energy is transferred to the wheels. Well, I work with an engine that's a little bit different than the one you would find in a car. It's bolted down to the ground, so it's not going to go anywhere anytime soon. But what makes it really special is that it has parts made out of glass, so that you can see inside it as the fuel burns. We have two problems though. One of them is that while you might think of fuel burning as a bright explosion, sometimes it's more like the dim burning flame of a natural gas stove. Trying to see anything in this case is like taking a picture in a dark room without a flash. The second problem is that we need to measure temperature and fuel concentration. This helps researchers identify problems and think of solutions. Just as an example, if fuel in the cylinders, if only part of the fuel is burnt, we could learn why the other part is being wasted, and we could think of what we could be doing differently. So, as interesting as a transparent engine is, by itself, it's not quite as useful. We still need to solve these two problems to really extract the information we need. There are already some solutions out there, but they're very expensive, and they require a very high level of training to be used, which really slows down technological advance. I am developing a method that could be significantly cheaper and less complicated. It's based on fireworks. That's right. The same substances that you see burn in the sky on 4th of July shine as brightly when you mix them with fuel and throw them in an engine as they do in the sky at night. And they have very useful properties. The relative brightness of the different colors could be an indication of temperature and fuel concentration. For example, for the substances that I currently use, I could measure these quantities by comparing the brightnesses of the red, the orange, and the violet light. In this way, fireworks could play a role in solving the energy problem, which is one of the most challenging of our time. I'm hoping that with their help, more researchers will be able to see processes that take place inside the engine, learn more about how fuel burns, and that eventually we all save at the pump and live in a cleaner planet.